Here is one more topic to discuss, Gauss-Seidel iteration method. Iteration you can call it as approximation. This is the last topic in Unit 1 matrices. Here we will consider the system of equations a11x1 plus a12x2 plus a13x3 equals to b1 constant, and a21x1 plus a22x2 plus a23x3 is equals to b2, and a31x1 plus a32x2 plus a33x3 equals to b3. So I am taking these all equations as 1. First point, where the diagonal coefficients are not 0. And second point, are large compared to other coefficients. So such a system of equations is called as diagonally dominant system. For example, if I take a11, modulus of a11, coefficient of x1 greater than modulus of a12 plus modulus of a13, and if I take a22 from this equation, modulus of a22 greater than or equal to modulus of a21 plus modulus of a23, and similarly taking a33 from this equation, mod of a33 greater than mod of a31 plus mod of a32. So these type of conditions are known as diagonally dominant system. So compulsorily the one coefficient from the equation should be greater than sum of other two. If you see here the system of equations, of that one can be written as x1 is equals to, so this dominant is satisfied by this first equation. Then from this a11 x1 is equal to b1, and send these two terms to the right hand side, and that becomes here x1 is equals to b1 minus a12 x2 minus a13 x3. And one more thing here, send this coefficient of x1 to the right hand side, then it goes into the denominator and it becomes 1 by a11. Similarly write the x2 from the second equation, that becomes 1 by a22 of b2 minus a21 x1 minus a23 x3. x3 equals to 1 by a33 b3 minus a31 x1 minus a32 x2. So let this be as equation 3, equation 4 and equation 5. Let the initial approximation solution be x1 of 0 minus x2 of 0 and x3 of 0. First approximation or first iteration comes as substitute x2 of 0 as 0 and x3 of 0 equals to 0 in equation 2, in equation 3. Then equation 2 comes as x1 is equals to a11 a11 of b1 minus a12 x2 minus a13 x3. Then if we substitute there x1 of 1, we are taking as 1 here because it is a first iteration method, equals to 1 by a11 of b1 minus a12 of x2 of, initially we are taking it as 0, then minus a13 x3 of 0. So this is our first x1. Next, similarly we write the x2 as x2 of 1 is equals to a22 of b2 minus a21 x1 of, here from this we will get the value of x1 of 1, then substitute that x1 of 1 in the x2 of 1, then x1 of 1 minus a23 x3 of, so till we don't know the value of x3, then take it as 0, x3 of 0, then x3 of 1 equals to 1 by a33 of b3 minus a3 x1 of, now here we got already the value of x1, then x1 of 1 minus a32 x2 of, here also we got the x2 value, then x2 of 1, then you will get the value of x3 of 1. Then next we have to go through the second iteration. First substitute x2 of 1, whatever the value we get here, then that's substitute that x2 of 1 and x3 of 1 in equation 3. So here also you can write it as substitute of x1 of 1 and x3 of 0 in equation 4. Then here comes as x1 of 2. We are taking 2 because we are in the second iteration method. Then x of 2 is equals to 1 by a11 of b1 minus a12 x2 of 1 minus a13 x3 of 1. So we are substituting the values of x2 of 1 and x3 of 1 which we got in first iteration method. Next, substitute x1 of 2 and x3 of 1 in equation 4. Then we get it as x2 of 2 equals to 1 by a22 of b2 minus a21 x1 of 2 and substituting these values of x1 of 2 and x3 of 1, that is x1 of 2 minus a23 x3 of 1. From this you will get the value of x2 of 2. Next, substitute x1 of 2 and x2 of 2 in equation 5. Then you will get it as x3 of 2 equals to 1 by a33 of b3 minus a31 x1 of 2. So from this you will get the value of x1 of 2 and from this you will get the value of x2 of 2. So substitute both in this equation of x3 of 2 minus a32 x2 of 2. So here we get the equations, and at last the iterations or approximations process will be continued until the two successive iterations or approximations are nearly same. So you will get to understand about this process more clearly when we solve one example problem based on this topic. We go with one problem. Use Gauss-Seidel iteration method to solve 10x plus y plus z equals to 12, 2x plus 10y plus z equals to 13, and 2x plus 2y plus 10z equals to 14. First, write the given equations are, and let this be as first, second and third equation. Conditions are here. From equation 1, I took 10, mod of 10 is greater than or equal to mod of 1 plus mod of 1. And from second equation, I took the coefficient of y as mod of 10 greater than or equal to mod of 2 plus mod of 1, which are the coefficients of x and z. Then 10 greater than or equal to 3. It's true. Then next, coefficient of z from the third equation comes as mod of 10 greater than or equal to 2 plus 2, which is 4. 10 greater than or equal to 4. Therefore, conditions are satisfied by 3 equations. Now from this, based on this, write the equations as x is equals to 1 by 10 of 12 minus y minus z. Let this be as equation number 4. So from here 10x plus y plus z equals to 12, and send this y and z terms to the right hand side. Then it becomes 12 minus y minus z. Then send this 10, which is multiplying by with x, send this to the right hand side. Then it will be divided by 10. That is what we got here. X is equals to 1 by 10 of 12 minus y minus z. Similarly, write the equation from the second as y is equals to 1 by 10 of 13 minus 2x minus z. Let it be as equation number 5. Equals to 1 by 10 of 14 minus 2x minus 2y. Let this be as equation number 6. Next, first iteration method. Substitute y of 0 is equal to 0 and z of 0 is equals to 0 in equation number 4. Then we get it as x of 1 equals to 1 by 10 of 12 minus y of 0 minus z of 0. That is equals to 1 by 10 of 12 minus y of 0, initially we are taking it as 0, minus z of 0 is 0. Then we get it as 12 by 10. Now use the calci. First click on and use this fractional one and enter the numerator as 12 and click on this button. You will get the cursor into the denominator and enter value 10, which is equal to 6 by 5, and use here s by d. Then you will get the number into decimal point. We got it as 1.2. Next, y of 1 equals to 1 by 10 of 13 minus 2 into x of 1 minus z of 0. So we got the x of 1 value here. Then we have to take this. Now we didn't get the z of 0. Then take it as 0. That is equals to 1 by 10 of 13 minus 2 into x of 1 is 1.2 minus z of 0 is 0. Then this comes as 13 minus 2 into 1.2 divided by 10. Now click on the AC to clear that previous answer. Click on the fractional one and enter the values in numerator. 13 minus 2 into 1.2 and click on this denominator. You will get the cursor into the denominator and enter value 10. That is equal to, get as 53 by 50 and click on this s by d. You will get into the decimal as 1.06. Write the value here 1.06. So y of 1 we got it as 1.06. Next, z of 1 equals to 1 by 10 of 14 minus 2 into x of 1, and we also got the value of y of 1 and write the value y of 1. Now that is equals to 1 by 10 of 14 minus 2 into x of 1 is 1.2 minus 2 into y of 1 we got it as here 1.06. Now solve this using calci. Click on AC, fractional 1, and 14 minus 2 into 1.2 minus 2 into 1.06, and click on this, enter the value 10, that is equal to 237 by 250, and click on S by D, 0.948, that is the value of Z of 1, 0.948. Next we will go into the second iteration method. Now at first substitute y of 1 and z of 1 in equation 4. Then x of 2 equals to, second iteration method, x of 2 equals to 1 by 10 of 12 minus y of 1 minus z of 1. Then that is equals to 1 by 10 of 12 minus y of 1 we got the value as 1.06 minus z of 1 is 0.948. Then that is equals to, now use the calci, click on AC, then enter the values, click on fractional 1, and 12 minus 1.06 minus 0.948, and click on this, get the cursor into the denominator, enter the value 10. Click on S by D, enter the values 0.93999. So up to 3 digits, after the decimal point up to 3 digits is enough. Now to get the value of y of 2, y of 2 is equals to 1 by 10 of 13 minus 2 into x of 2, because here we are taking x of 2, we already got the value of this. Then minus z of 1. Then y of 2 equals to 1 by 10 of 13 minus 2 into x of 2 is 0.999 minus z of 1 is 0.948. Then that is equals to, click on AC, fraction 1, and 13 minus 2 into 0.999 minus 0.948. Click on this, get the cursor into the denominator, enter the value 10, that is equal to, and click on S by D, you get the value as 1.0054. So this is the value of y of 2. Next, z of 2. Z of 2 equals to 1 by 10 of 14 minus 2 into x of 2 minus 2 into y of 2. Then that is equals to 1 by 10 of 14 minus 2 into x of 2 we got it as 0.99999 minus 2 into y of 2 value we got it as 1.0054. We can take up till 5. Then that is equals to, click on AC, the fractional 1, and 14 minus 2 into 0.999 minus 2 into 1.0054. Click on this, get the cursor into the denominator, enter the value as 10, that is equal to, got the value as 0.999. So as I told you to take the 3 digits, then I am taking it as 0.999. Iteration follows as x of 3 equals to 1 by 10 of 12 minus y of 2 minus z of 2. Then that is equals to 1 by 10 of 12 minus y of 2, we got the value as 1.0054 minus z of 2, we got it as 0.99. Then you get the value as, click on AC and fractional one, 12 minus 1.0054 minus 0.999 and get the cursor into the denominator, click on, enter the value as 10, we get it as 0.999. That is the value of x of 3. Next, y of 3 equals to 1 by 10 of 13 minus 2 into x power x of 3 minus z into x of 2. Then that is 1 by 10 of 13 minus 2 into x of 3 is, we got it as 0.999 minus z of 2 here 0.999. Now use the calci, click on AC, fractional one, and 13 minus 2 into 0.999 minus 0.999 and enter the value 10, that is equal to, click on S by D, you got the value as 1.003 and approximately 1.000. Then fourth iteration, then x of z of 3 equals to 1 by 10 of 14 minus 2 into x of 3 minus 2y of x of 3. Enter the values of x of 3 and y of 3. That is equal to 1 by 10 of 14 minus 2 into x of 3 value, we got it as 0.999, 2 into 1.000. Now click on the fraction button, 14 minus 2 into 0.999 minus 2 into 1.000 and get the cursor into the denominator, enter the value 10 equals to, you get the value as 1.000. Next, fourth iteration, follows as x of 4 equals to 1 by 10 of 12 minus y of 3 minus z of 3, that is equal to 1 by 10 of 12 minus 1.000 minus 1.000. Now enter the value here on fraction 1 and 12 minus 1.000 minus 1.000. Get the cursor into the denominator, enter the value 10 equals to, we got it as 1. Then y of 4 equals to 1 by 10 of 13 minus 2 into x of 4 minus z of 3. Then that is equals to 1 by 10 of 13 minus 2 into x of 4, we got it as 1 minus z of 3 is 1.000. Then that is equals to, click on AC, click on fractional one and 13 minus 2 into 1 minus 1.000. Get the cursor into the denominator, enter the value 10 equals to 1. Then z of 4 equals to 1 by 10 of 14 minus 2 into x of 4 minus 2 into y of 4. Then that is equal to 1 by 10 of 14 minus 2 into x of 4 is 1 minus 2 into y of 4 is 1. Then that is equals to, click on AC, fractional one 14 minus 2 into 1 minus 2 into 1. Get the cursor into the denominator, enter the value 10, that is equal to 1. So we got the value of x of 4 is 1, y of 4 is 1 and z of 4 is 1. Here third iteration we got x of 3 value as 0.999 and it is approximately equal to 1, and here y of 3 1.00, that is approximately equal to 1, and z of 3 1. In fourth iteration also we got it as x of 4 1, y of 4 1 and z of 4 1. So therefore third and fourth iterations are equal. Therefore the solutions are x is equals to 1, y is equals to 1 and z equals to 1. So in this way we will find the values of x, y and z using Gauss-Seidel iteration method. Thank you.